Hi, in this video I'm going to be talking about similarity, and in fact we're going to talk actually about a couple of things first before we get into similarity as it deals with geometry, with shapes. We're going to deal with a couple of algebra things, namely ratio and proportion, and this first video is going to be strictly on just ratios and what ratios are. So we're going to focus on this video on ratios, and then next we'll talk about proportions, which is when I put a couple of ratios and I set them equal to each other. So the first thing to understand is that a ratio is just a comparison between two values. Okay, so all I'm going to do is I'm going to take two values, A and B, and I can write it a few different ways. I can say the ratio of A to B. I can say the ratio of A to B this way with a colon in the middle, or I can write it as a fraction, and notice it says where B is not 0. Keep in mind that we're going to be dealing with like triangles and polygons and stuff like that. So and these are going to represent like measurements, like maybe side lengths or angles or something. You're never going to have 0 when you're dealing with geometry shapes, but we don't want to be able to divide by 0. We need to be able to say, hey, listen, this is okay as long as we're not dividing by 0. That's all this statement means. Don't get too hung up on it, okay? But you could probably guess we have, like, please excuse my dear Aunt Sally, right, to deal with algebra and how to solve algebraic equations. Well, you'll never see the word 2 show up in your algebra equation, and you'll never see a colon show up. You will see fractions. And so we're going to stick to this format is how you're going to see it written most of the time, because that's something we know how to work with. We know how to solve for x if x is in that fraction, right? Whereas over here, a little bit tougher. So, examples. Maybe I say if I have a 1-to-2 ratio, I'm saying one thing is twice as big as the other. 2-to-1 ratio, 1-to-2 ratio. Then I can write it as 1-to-2 with the word 2 in there. I can write it as 1-to-2 with a colon, or I can write it as 1-to-2 as a fraction. So let's go take a look at a couple of examples, some applications, right? First of all, slope, right? Slope can be thought of maybe as a ratio, and the ratio might be something like rise over run. Let's cover this up for just a second so you're not getting concerned about it. Like my old school paper and pencil approach, I bet, huh? Slope can be thought of the ratio as rise and run. And so I could write it with a colon, I could write it with the word 2, but you're going to see here, we want to work with fractions. So maybe I write it as rise to run. There's the ratio of rise to run. Oh, that looks exactly like what you've been doing in Algebra 1 and middle school math, right? It's slope, rise over run. So if we wanted to ask what the ratio of rise to run would be, that's asking the same thing as what slope would be. You've done this problem many times. I would say, well, look, this has got a height of -1, according to the y-coordinate here. This is at a height of 3. So I go up 1 unit to the axis, another 3 units. That's a grand total of 4, right? And I look over here and I say, well, look at this. This is an x-coordinate of -2, and this is an x-coordinate of +4. And so I'm going 2 units to the axis, and I'm going to go 4 more, and that's a grand total of 6. So the ratio of rise over run, rise to run, would be a 4 to 6 ratio. But we need to be careful, because anytime we write a ratio as a fraction, if it reduces, we need to do so. 4 over 6 does reduce. It reduces to 2/3. So we would say the ratio would be 2 to 3 of rise to run. Pretty simple problem, right? You've done that a lot. Now, let's go look at this. A ratio can involve more than 2 numbers. So, for example, if I have a rectangle, and I could say the ratio of the side lengths of that rectangle is a 3 to 7 to 3 to 7 ratio. And all I'm saying is that if I have, I don't know what this is, but maybe this is 3, and maybe this is 7, maybe this is 3, and maybe this is 7. But I want you to be careful, because just like fractions reduce, we could say, hey, what if this is twice as long? What if it was 6 to 14, 6 to 14? We really don't know. Well, the reason we don't write 6 to 14 up here is because it's not reduced. 3 to 7 is like the reduced form of that fraction, if we could write that as a fraction. You can see here why colons are necessary sometimes, right? Because you can't write that as a fraction over a fraction over a fraction. Notice I just made everything twice as big, right? Maybe this is 9 and that's 21, 9 and 21. Everything's 3 times as big. I really don't know, okay? And there are going to be times whenever we don't know the reduced form, and so we're going to write things in a different way in order to help us solve problems. You're going to see that in the next example. But that would be an example of what it might look like to have a rectangle with side length ratios of 3 to 7 to 3 to 7. So, let's go solve a problem. The ratio of the side lengths of a quadrilateral. Now, don't get hung up on this, okay? If you don't know what this is, this would be a good time to do like a Google image search and just type in quadrilateral, and you'll see 1,000 different pictures, and they all look the same, basically. But quad means 4, so really just have a 4-sided shape. It can't be a rectangle, because I know the side lengths are 2 to 3 to 5 to 7. You can't have a rectangle with 4 different side lengths, right? So this isn't a great picture. It's not accurate, but it'll do because it's got 4 sides. It says the ratio of the side lengths is 2 to 3 to 5 to 7, and the perimeter is 85 feet. Well, see, here's the problem. If this is really just 2, and this is 3, and this is 5, and this is 7, to find the perimeter, I would just add all 4 of the sides up. 2 plus 3 is 5, plus another 5 is 10, plus 7, 17, right? That's only 17 feet. I need 85 feet. So how do I know that it's not 4, 6, 10, 14? How do I know that it's not 6, 9, 15, 21? Everything's 3 times as big, right? So the quickest way to find this, how big is it, what am I multiplying everything by, is just to call everything 2x, 3x, 5x, and 7x. 2 times something, 3 times the same. So if it's tripled, if this is really a 6, it's 2 times 3. 3 times 3 is 9. 5 times 3, so on and so forth. You get my point? Here's what I know. Those 4 sides add up to 85. So let's do that. 2x plus 3x plus 5x plus 7x. Well, those numbers have to add up to 85. And like we said earlier, that's 17 x's, right? Well, if 17x is equal to 85, I divide both sides by 17, and I get x is equal to 5. So I know x is 5. Everything's 5 times as big as whatever I thought it was. So 2 times 5 becomes a 10. 3 times 5 becomes a 15. 5 times 5 becomes a 25. And 7 times 5 becomes a 35. Those are the 4 measurements that I actually have, and that is a 2 to 3 to 5 to 7 ratio. So the length of the longest side would obviously be the 7x side, the 35. So that would be 35 feet. That would be the answer to this question. Does that make sense? Okay, one more. That one's pretty explicit. By the way, know that perimeter is adding up all the sides. That'll come in handy. You'll be doing that on your homework, I'm sure. Last problem. The ratio of the angle measures in a triangle is 1 to 6 to 13. So what's the measure of each angle? Well, if I was just 1 degree and 6 degrees and 13 degrees, that's only 20 degrees total. 1 plus 6 plus 13 is 20. So it can't be that, because I know the 3 angles inside of a triangle add up to 180, right? So instead, I'm going to write 1x, 6 x's, and 13 x's. And here's what I know. Those 3 values add up to 180 degrees. So x plus 6x plus 13x is equal to 180. That's what I know. That would be 20 x's, which is equal to 180. And if 20 x's is equal to 180, that means each x is 9. So that means that this angle here is actually just 9 degrees. This is 6 times 9, which is 54 degrees. And this is 13 times 9, which is, 117 maybe? Let me check. Yep, 117 degrees, okay? So the measure of each angle, if they wrote it like this, you could say 9 degrees, 54 degrees, and 117. I would write it in that order. In fact, I would write it in this format. They gave it to me as a ratio with colons. So I'm going to go ahead and write my answer as a ratio with colons, okay? Since they didn't ask like a specific one, like what's the largest angle. Well, if that makes sense, then you're probably ready to get going on some of the homework that deals with well, actually, most of your homework actually doesn't deal with this. To be honest, it deals with proportions. You're ready to go on and watch the next video is what you're ready for. So, if you have any questions, please shoot me an email, do something, figure out what you need to know. But this is the basic problem that you have to be able to do. These are all type 1, type 2 problems.